Hello everybody, welcome into another lesson. So today we are going to solve some very basic rudimentary trig equations. Up till now you've been taking like the sine of 30 degrees equals 1/2 or the sine of 60 equals a square root of 3 over 2, and you've been doing this with all 6 trig functions. The goal of today's lesson is we're going to work backwards, if you will. We're going to find what that value of theta is. And for every angle, there are actually 2 values of that in the interval from 0 to 360 if you're going in degrees, and from 0 to 2 pi if you're doing it in radians. Now, some of you who know some trig already may say, well, couldn't we just use the inverse trig functions? Yes, but those only cover a certain specific range, which actually would not cover what we're trying to do today. They could give you a rough framework, but that doesn't really fully solve the equation. That's why we're not doing inverse trig functions today, and teaching inverse trig functions is actually better once you understand how to graph regular trig functions. But anyway, we are going to find 2 angles that satisfy this equation in degrees from 0 to 360 and in radians from 0 to 2 pi. And I've set us up on the right hand side here a 30, 60, 90 right triangle and a 45, 45, 90 right triangle. These are infinitely useful, and I've been doing this for 10 plus years with trigonometry, and I still use these triangles. I still draw them. It helps me know what I'm visualizing. So that's why I've been preaching since geometry and all through Algebra 2 trig and even now in Precalc, and I'll say it again in calculus when we get there. These triangles are infinitely useful. Keep these. Memorize your 30, 60, 90, and 45, 45, 90 triangles. You are always going to use them. So for the first one here, we have the sine of theta equals positive 1/2. Well, let's start with a regular angle that would equal 1/2. That, of course, the sine's definitely positive in the first quadrant, but it's also positive in the second quadrant, right? Well, why don't we start with the first quadrant angle? So the sine of theta equals 1/2. Well, if you look at your triangles, the sine of 30 equals 1/2. So you'll definitely have a 30-degree angle. And then we've also stated that the sine's positive in the second quadrant. So that means you're going to take that 30, subtract it from 180, so 150 degrees would also satisfy this equation. We found the answers in degrees. They also ask for it in radians. Well, 30 degrees in radians, that's going to be pi over 6. And then 150 degrees in radians, so you're going to take that pi over 6, subtract it from pi, you'll get 5 pi over 6. So the 2 angles that will satisfy this equation are 30 degrees or pi over 6, and then 150 degrees or 5 pi over 6. And if you put these values in, you would see what I'm saying is true. They would equal 1/2. Okay. Now let's change this a bit. We're going to do the sine of theta equals negative 1/2. So we need to find 2 angles, both in degrees and radians, from 0 to 360 and 0 to 2 pi. Well, when is the sine negative? That's going to be in the third and fourth quadrant, right? So we're looking for angles in the third and fourth quadrant. Well, if you look at your 30, 60, 90 triangle, you see the sine of 30 equals 1/2. So it's going to be based off a 30-degree angle, very much so. However, you can only pick it in the third or fourth quadrant because that's where the sine's negative. So take that 30 to get your third quadrant angle, you'll add that 30 to 180, you would get 210 degrees. And then to get your fourth quadrant angle, you'll take that 30, you'll subtract it from 360, you would get 330 degrees. So those are your degrees. Now let's figure this out in radians. Well, 30 degrees is pi over 6. To get your third quadrant angle, add pi over 6 to 180 to pi rather. You'll get 7 pi over 6. And then take that pi over 6, subtract it from 2 pi. To get your fourth quadrant angle, you would end up getting 11 pi over 6. So the two angles that would satisfy this equation would be 210 degrees and 7 pi over 6 radians, or 330 degrees and 11 pi over 6 radians. All right. Let's change this equation this time. So we have the cosine of theta equals the square root of 2 over 2. So we've been given the cosine of theta equals the square root of 2 over 2. Well, that's the same as 1 over the square root of 2, right? So where does the cosine of theta equal positive 1 over the square root of 2, or positive 1 over the square root of 2, or positive square root of 2 over 2? The cosine's always positive in the first and fourth quadrants, right? So let's look for the first quadrant angle. Well, you get that value, cosine of 45 is 1 over square root of 2, which is the square root of 2 over 2. So for sure you'll get 45 degrees. And then we also stated that this occurs again in the fourth quadrant where the cosine's positive. So you're going to take that 45 degrees, subtract it from 360, you would end up getting 315 degrees also. Now, those are your degree measures. What about your radians? So 45 degrees in radians, that's pi over 4. And then to get your fourth quadrant radian measure, take that pi over 4, subtract it from 2 pi, you should get 7 pi over 4. So the angles that would satisfy theta are 45 degrees and pi over 4 radians, or 315 degrees and 7 pi over 4 radians. All right. So now the cosine of theta this time equals negative of the square root of 2 over 2. So the cosine of theta equals negative square root of 2 over 2. Where is the cosine negative? That's in the second and third quadrants, it's negative, right? Well, we have something similar. If you take the cosine of 45, you get 1 over the square root of 2, which is square root of 2 over 2. So we know it's going to be based off of a 45 degree reference angle. Now we got to figure out the second quadrant equivalent to that. So you'll take 180 minus 45, you would get 135 degrees. And then you got to figure out a third quadrant equivalent to that. So add 45 to 180, you would get 225 degrees. So those are your degree measures. Now what about your radians? So 45 degrees is pi over 4, so to find your second quadrant equivalent, subtract that from pi, you would end up getting 3 pi over 4. And then to get your fourth quadrant equivalent, take that pi over 4, add it to pi, you would get 5 pi over 4. So in degrees, you would have 135 degrees paired with 3 pi over 4 radians, and then 225 degrees paired with 5 pi over 4 radians. What's next here? Good one. Cosecant of theta equals 2 times the square root of 3 over 3. Well, It might be useful. Normally I don't suggest this, but you actually might want to rationalize the numerator in this case, which would simply just give you 2 over the square root of 3. Now we have a form we can recognize more. The cosecant of theta equals 2 over the square root of 3. Well, okay, what is the cosecant in general? It's the reciprocal of the sine function. So we're looking for a positive cosecant, which is based off a positive sine. When is your sine and thus your cosecant positive? In the first and second quadrant, right? Well, okay, so that means we need to find an angle in the first and in the second quadrant. Cosecant is hypotenuse over opposite. If you look at 60 degrees, you take the hypotenuse over the opposite side, you would get 2 over the square root of 3. So for sure you have 60 degrees. Then you got to find a second quadrant equivalent. So take 60, subtract that from 180, you'll get 120 degrees. And then now we need to convert these to radians. So 60 degrees is the same as pi over 3 radians. And then 120 degrees, so take that pi over 3, subtract it from pi, you end up getting 2 pi over 3. So the two angles that satisfy this equation are 60 degrees or pi over 3 radians and 120 degrees or 2 pi over 3 radians. Alright, good one also. Cotangent of theta equals -1. So we have the cotangent of theta equals -1. Well, where is your cotangent negative? That's in the second and fourth quadrants, so this one's a little bit different. Well, if we look at our triangles, cotangents adjacent over opposite, well, at 45 degrees, the cotangent would be +1. So it's going to be based off of a 45-degree reference angle. Well, we stated that one cotangent angle is negative in the second quadrant. So take that 45 degrees, subtract it from 180, you should end up getting 135 degrees. And then you want to do the same thing in the fourth quadrant. Take that 45, subtract it from 360, you should get 315 degrees. Now, in general, what is 45 degrees? That's pi over 4, right? So if you're in the second quadrant, take that pi over 4, subtract it from pi, you would end up getting 3 pi over 4 for your radians. And then that 315 degrees, so take that pi over 4, subtract it from 2 pi, you should end up getting 7 pi over 4. So what you should get for theta is 135 degrees or 3 pi over 4 radians, and 315 degrees or 7 pi over 4 radians. Alright, let's see. Cosecant of theta equals -√2. So the cosecant of theta equals -√2. Well, again, your cosecant's going to be negative in the third and fourth quadrants, right? Well, if we look at our 45, 45, 90 triangle, we know the cosecant of 45 is √2 over 1, which is √2. So this is going to be based off of a 45-degree reference angle. So we're in the third and fourth quadrant, so take that 45 degrees, add it to 180 to get your third quadrant angle. You would end up getting 225 — and then to find your fourth quadrant angle, take that 45, subtract it from 360, you end up getting 315 degrees. And then we want to find this in radians. So 45 degrees is pi over 4. So to find your third quadrant angle, add that to pi, you end up getting 5 pi over 4. And then in the fourth quadrant, take that pi over 4, subtract it from 2 pi, you end up getting 7 pi over 4. So the two angles that would satisfy this are 225 degrees or 5 pi over 4 radians, or 315 degrees and 7 pi over 4 radians. Alright, let's see. We have the cosecant of theta equals positive 2. So we got the cosecant of theta equals positive 2. Well, where's the cosecant positive? That's going to be in the first and second quadrants, right? If we look at our 30, 60, 90 right triangle, the cosecant of 30, well, that's going to be hypotenuse over opposite, 2 over 1, which is 2. So for sure we have 30 degrees. Then we need to find the second quadrant equivalent to that. Take that 30 from 180, you'll end up getting 150 degrees. Now we need to convert these to radians. So 30 is the same as pi over 6 radians. And then 150 degrees, so take that pi over 6, subtract it from pi, you end up getting 5 pi over 6. So the two angles that satisfy this are 30 degrees or pi over 6 radians and 150 degrees or 5 pi over 6 radians. Alright, 4 more of these and we move on to the next part. So we have the secant of theta equals negative 2 times the square root of 3 over 3, which is going to be the same thing as negative 2 over the square root of 3. Now we got a form we can more recognize. So where is the secant negative? That's the reciprocal of the cosine, so that's negative in the second and third quadrants. So we need to deal in the second and third quadrants. So if we look here at our 30, 60, 90 right triangle, the secant is the hypotenuse over adjacent. Well, the secant of 30 is 2 over the square root of 3. So this is going to be based off a 30-degree reference angle. Well, we're in the second and third quadrant, so in the second quadrant, take that 30 and subtract it from 180, you get 150 degrees. And then in the third quadrant, take that 30-degree angle, add it to 180, you'll end up getting 210 degrees. So there's your degrees, let's find your radians. So that 30 degrees is the same as pi over 6, subtract that from pi, you end up getting 5 pi over 6. And then to get your third quadrant radian measure, take that pi over 6, add it to pi, you get 7 pi over 6. So you should get 150 degrees or 5 pi over 6 radians, and then 210 degrees or 7 pi over 6 radians. Okay, 3 more. So the cosine of theta equals negative 1/2. So we've been given that the cosine of theta equals negative 1/2. Well, where's the cosine negative at? In the second and third quadrants, right? If we look at our 30, 60, 90 triangle, if we take the cosine of 60, so adjacent over hypotenuse, that's going to be 1/2. So this is going to be based off of a 60-degree reference angle. In the second quadrant, subtract that from 180, you definitely get 120 degrees. In the third quadrant, you'll take that same 60, add it to 180, you'll end up getting 240 degrees. Now we need to find radian measures. So 60 degrees is the same as pi over 3, so subtract that from pi in the second quadrant, you would end up getting 2 pi over 3. And then to get your third quadrant equivalent, take that pi over 3, add it to pi, you would end up getting 4 pi over 3. So the two angles you should get are 120 degrees or 2 pi over 3 radians and 240 degrees or 4 pi over 3 radians. Got two more of these. All right. Cotangent of theta equals negative of the square root of 3. So we've been given that the cotangent of theta equals negative square root of 3. Well, where's the cotangent negative? In the second and fourth quadrants. So if we look at our 30, 60, 90 right triangle, cotangent, of course, is adjacent over opposite. So the cotangent of 30 is the square root of 3 over 1, which is the square root of 3. So we're going to go based off of a 30-degree reference angle. Well, in the second quadrant, subtract that 30 from 180, you'll end up getting 150 degrees. And then it happens again in the fourth quadrant. So take that 30, subtract it from 360, you'll also get 330 degrees. Now in radians, so 30 degrees in general is pi over 6. So in the second quadrant, take that pi over 6, subtract it from pi, you end up getting 5 pi over 6. And then in the fourth quadrant, take that pi over 6, subtract it from 2 pi, you end up getting 11 pi over 6. Alright, so the two angles you should get are 150 degrees or 5 pi over 6 radians, and 330 degrees or 11 pi over 6 radians. One more of these, then we'll do some function operations. Alright. Secant of theta equals the square root of 2. Yep, secant of theta equals the square root of 2. Well, secant's the reciprocal of cosine, so where's your cosine positive? In other words, then where's your secant positive? In the first and fourth quadrants, it is. So if you look at your 45, 45, 90 right triangle, we know secant is hypotenuse over adjacent. So 45 degrees, the secant is square root of 2 over 1, or simply the square root of 2. So for sure you'll have 45 degrees. And then your fourth quadrant equivalent, take 45 away from 360, you end up getting 315 degrees. Alright, now let's find this in radians. Find these in radians. So 45 degrees itself is pi over 4. And then the 315 degrees, so take pi over 4 away from 2 pi, you end up getting 7 pi over 4. So the two angles that you should get are 45 degrees or pi over 4 radians and 315 degrees or 7 pi over 4 radians. So those are solving very rudimentary basic trig equations. Now, we're going to do some function operations here. Let's see. Perform the function operations for f of theta equals sine of theta and g of theta equals the cosine of theta. So we're going to do some function operations here. We're given that f of theta equals sine of theta and g of theta equals the cosine of theta. So we're going to do it here for theta is 30 degrees. Alright, so we're going to start with theta's 30 degrees. They want us to find f of theta plus g of theta, which in this case, alright, so theta's 30 degrees, f is sine, so this would be the same as the sine of theta plus that g of theta, so that would be the cosine of theta, which in this case, theta's 30 degrees, so this would be the sine of 30 degrees plus the cosine of 30 degrees, which now it's just a matter of finding these values and plugging them in. So the sine of 30 is 1 over 2, so that would be the same as 1/2 plus, then you have the cosine of 30, which would be the square root of 3 over 2. Which, if you want to write this as one denominator, it'd be 1 plus the square root of 3 over 2. So the sine of 30 plus the cosine of theta equals 1 plus the square root of 3 over 2. That one wasn't so bad. Alright. What about, let's see, we're going to take g of theta minus f of theta. Well, g of theta is the cosine of theta minus that f of theta, which is sine of theta. In this case, that's the cosine of 30 degrees minus the sine of 30 degrees. Now the cosine of 30 adjacent over hypotenuse, that's a square root of 3 over 2, minus your sine of 30, that's 1 over 2. And you could honestly leave it like this, that'd be fine. You would end up getting the square root of 3 over 2 minus 1/2 for that answer. What are we going to do next? Good one. We're going to take g of theta squared. G of theta squared, so g of theta is cosine of theta. That's going to be cosine of theta squared, which is the same thing as writing cosine squared of theta. Trigonometric functions are the only functions where you have that power in between the three letters and the variable you're using. I don't know why that is, but that's what mathematicians found conventional to do for trig functions. Theta in this case is 30 degrees, so that's going to be the cosine squared of 30 degrees. Well, what is the cosine of 30? That's the square root of 3 over 2, so you're going to take that square root of 3 over 2, raise that to the second power. That would just give you 3/4. So the answer you should get in the end would be 3/4. All right. Now we're going to take f of theta times g of theta. F of theta times g of theta, well, that equals the sine of theta times the cosine of theta. In this case, since theta is 30, that's going to equal the sine of 30 degrees times the cosine of 30 degrees. So what is the sine of 30? That's going to be 1/2, so you'll end up getting 1/2 times your cosine of 30 is the square root of 3/2, which when you multiply, you should get the square root of 3/4. So what you should get in the end here is the square root of 3/4. Alright, let's take 2 times f of theta. 2f of theta, well f of theta is the sine of theta, so that's going to be the same then as 2 sine of theta, which in this case is 2 times the sine of 30 degrees. Now what is the sine of 30? That's going to be 1/2, so you'll take 2 times 1/2, which would just give you 1. So the answer you should get in this case would end up being 1. And I got one more of these, then we'll do one more set of exercises with these, then we'll be done. Alright. Let's take g of negative theta. This is actually a very good one. So g of negative theta, what is g of theta in general? That's going to be the same as the cosine of negative theta. Okay, well, before we go making this all complicated, do we remember the even and odd properties of trig functions? Cosine's an even function, so the cosine of negative theta is actually going to be the same as the cosine of regular theta, since it's an even function. And they give you that theta is 30 degrees, so literally all you have to find is the cosine of 30 degrees, which in this case is going to be the square root of 3/2. So you should end up getting the square root of 3/2. And I got one more set of these. This time let's do that theta equals 5π/2. Well, they're really trying to trick you here, aren't they? 5π/2, well that's greater than 2π, isn't it? Because 2π is 4π/2. That's a whole π/2 past it. If you have an angle greater than 2π, just subtract 2π from it, you'll get the exact same thing. It would be the same as π/2. That should make your life a lot easier now, since you're just working with π/2. So we're of course going to take f of theta plus g of theta, which f of theta is the sine of theta, plus that g of theta is the cosine of theta, which in this case would be the sine of π/2 times the cosine of π/2. Not times, what am I saying? Excuse me, that's not times, that's plus the cosine of π/2. Excuse me. Oh boy, long day. Alright, so what is the sine of π/2? At π/2 you have the coordinate 0, 1, right? And the sine's your y value, so sine of π/2 is 1, plus now the cosine of π/2, that's your x value, which would be 0. So you'll literally have 1 plus 0, which would just end up giving you 1. So you should end up getting 1 for that answer. Alright. Next we're going to do g of theta minus f of theta. Well, g of theta has been established to be the cosine of theta, minus that f of theta, which is sine of theta. So, in this case, we're taking the cosine of pi over 2 minus the sine of pi over 2. Alright, so what is the cosine of pi over 2? That's just 0, right? And then the sine of pi over 2, so minus that value, the sine of pi over 2 is 1. So you have 0 minus 1, which should give you an answer of -1. That's what I thought it was. Okay. This time we're going to do g of theta squared. Well, g of theta is cosine of theta, so this is the same as the cosine squared of theta. Well, we're dealing with pi over 2, so this would be the cosine squared of pi over 2. Well, what is pi over 2? That's 0, so this is the same as 0 squared, which we better know as 0. So you get a big fat 0 for that answer. Three more, then we're done. Alright, so let's take f of theta times g of theta. F of theta is the sine of theta, so we'll take the sine of theta times the cosine of theta. Alright, so in this case we're taking the sine of pi over 2 times the cosine of pi over 2. Well, alright, so what is the sine of pi over 2? That's 1. That would equal 1 times what's the cosine of pi over 2? That's 0. Well, 1 times 0 is 0. So you also get 0 for that answer. Two more and we're done. Alright, 2 times f of theta. Well, f of theta was sine of theta, so this is the same as 2 times the sine of theta. Well, what is theta? That's pi over 2, so we're going to take 2 times the sine of pi over 2. Alright, so what is sine of pi over 2? That's 1, so you would take 2 times 1. You should end up getting an answer of 2. So your final answer should be 2 for this. And one more. We're going to take g of negative theta. Well, g is cosine, so this would be the same as the cosine of negative theta. Actually, we'll do one more after this because I want to illustrate something. Okay, so what is the cosine of negative theta? Well, cosine's an even function, so that means this is going to just turn into the cosine of theta. Now it's just a matter of evaluating the cosine of pi over 2, which is going to give you 0. Easy enough, right? Now, last but not least, I do want to do, I'm making this one up here, but it's very valuable. Let's do f of negative theta. F is sine, so in other words, we're going to take the sine of negative theta. Now, what's true about the sine function? It's an odd function, so that sine of negative theta would just turn into negative of the sine of positive theta. Well, that's the negative of the sine of pi over 2. What is the sine of pi over 2? That's just 1, so literally your answer is going to be -1. So that's it for this lesson. Next lesson will be a little more exciting. We're going to start getting into some graphing trig functions. We'll focus exclusively on the sine and cosine functions for graphing those in the next lesson. So I hope everyone has a great day. Take care.